Let's write this down. Okay, so chapter 4, probability test checklist. Should have like over half a page on page 157 there. So obviously this isn't going to cover everything, but at least you have something to go by, something you need to know for sure. So the first thing is, and we started off with this, is theoretical versus experimental probability. And theoretical is what should happen. And obviously experimentals actually happened. But I'm going to take it a step further. I'm going to say that this one is favorable. So favorable is like what I'm after, like I want the blue, or I want, like I'm looking for rain tomorrow or not rain, right? That's the favorable outcome you're after over total possible. So that is theoretical. It's like we look at a deck of cards, you know, there's half of them are black, half of them are red. So let's say you want a black card. The favorable is 26, total possible 52, okay? So, and then experimental is still favorable over trials. It's the total trials that you've performed. So let's say you're actually now testing that and you're drawing cards from a deck of cards, right? And you're gonna come up with your own little experiment and see if it's in fact true that it's 1/2, right? It's 50%. And there's a problem with sample size. You have to do enough experiments to get these to be the similar. So that gets me to the second point. Know how sample size, I'm summarizing this, that's why it doesn't sound right. Know how sample size affects experimental probability, right? Increasing, right? Increasing sample will result in the following, right? That the theoretical probability should be close or approximately the same as the experimental probability. And we talked about a good sample is 10 to 25%. So for Sisler, for example, let's say round numbers, staff and students 2,000, right? So if you ask about 200 people minimum, you will probably get a pretty good idea if this is representative of the whole school, right? So if I ask people, hey, do you have a job? Yeah, right. I asked only this class. That's not good enough. I need to ask probably not only grade 12s, right? I should also ask grade 9, 10, right? Like diversify, but I have to have a good enough sample before I make my conclusions, right? Okay, number 3. Use probability of event to make predictions. And so prediction is always probability times large sample. This formula you should have somewhere in your study sheet already. Okay. And remember, Remember this, if even I can give you odds or probability. If it's probability, boom, you got it. If I give you odds, can you turn that into a probability? Yes, right? You can do that. So remember that. For odds, okay, never have the total in the ratio. Okay, this is very important. So probability to odds, right? If you're converting probability to odds, we're going to do that. Just a quick recap of that. Probability of, let's say we're looking for rain for farmers, right? You want it to rain, and the probability is 2 out of 9. And this is where it got some of you maybe a little confused. And I will take this chance to use my handout to explain why I have that branching out. If I give you a probability, you can get two odds from it. Odds for, odds against. Does that make sense? Right? So if I give you a probability, it will be a fraction. It could, and we're looking at a particular event, we call it A. If you want the odds in favor of this happening, A goes up front. Okay? If the question goes ahead and branches off and says, hey, find the odds against A happening. So let's say for us it's rain. You would put the A, like the amount of rain, on the other side of the ratio, right? So you got to make sure that for or against tells you where that event is going to be, the number of occurrences. So I'm going to branch off odds for rain in favor of rain would be 2, 2, 7, because you go 9 minus 2, right, to get the other side. Odds against rain is essentially just flipping that, right? But I always focus on the rain goes first on the other side, and then I go 9 minus 2 to get the other number. So it's essentially just flipping this one other side. Okay, so we're going to put that there. And then odds to probability. So let's say, I will say this. If you just hear odds, it's not enough. The question needs to tell you odds in favor or odds against. Right? If it just says odds, it's not good enough. So watch for the wording odds in favor. So I will say this, odds in favor of red queen. So let's say the question says, hey, the odds in favor of drawing a red queen would be how many red queens? 2, right? 4 queens, half of them are red, half of them are black, right? So 2, and then what's on the other side? 52, is that correct? Nope. Minus 2. Right? You got to take away the red queens from the pack now, right? So it's 2 to 50. This is that. So what's the probability of red queen? We would take that, right? We would say 2 of them are red over What are you going to do here? Add them up. Exactly, add them up. So 2 plus 50, that's 2 out of 52. So that's how probability is different. There's a total there, no total on the ratio, but you can come up with the total if you just add them up. And I could also say probability against a red queen would be 50 over 52. Right? So you know that one question on the quiz that I just gave you, the AC? It went probability first and then odds second. You got to be able to go back and forth and know what to write down when. Okay, 5. Dependent versus independent events. How do you know something is events are, yeah, go ahead. How do you know events are dependent? Keywords. Yeah. The first event affects the second. Do you know any keywords that how do we know? Yuri? Sorry. Samples? Is that what you said? Not quite. Angelica, and then Gino. If she doesn't get it, then you're. What's that? No replacement. Is that what you're trying to say, Gino? Yeah? Okay, let me just say it because some of you are falling asleep on me here. So wake up. If it says no replacement, things are not being put back, what do you know about that probability right off the bat? What happens to the bottom number? It goes down, right? Because you didn't put that one back. So guaranteed the denominator is going to be one less. So deck of cards, you started with 52, it's going to be out of 51. But it may or may not affect the top number. It depends on what happened before, right? So yes, here, dependent, no replacement. There will be several, like, how do you know this? How do you know that? And that's where you need to make sure you read up on things. So no replacement, and I will say this, total, always affected. Right, it's -1, right? Numerator may be affected. Okay, the numerator may be affected. It depends on the scenario. If you grab the blue marble first and you're looking for another blue marble second, absolutely you're down on blue marble because the first event brought down the blues, right? If you're drawing a blue marble first and then a green second, the first event did not affect the second event. So in a sense of the number of greens that you're looking for in the second. So watch out for that. Okay, last point. I'm going to make that here because I'm kind of running out of, if you're running out of room, just steal from the bottom here. Just kind of scratch this and just do the bottom there. So 6 expected value. Let me write down expected value like this. Expected value. And so EV can be positive, it can be 0, or it can be negative. So gain expected, break even, and loss, right? So those are your 3 options at the end. If I were to ask you, hey, should you play this game? If you get a positive answer, yes, you should. If it's negative, you shouldn't, right? And it's always in dollars. So write down next to expected value, write down the dollar amount. I'm not going to write this down, but I already told you about reviewing buying new versus used. And I did mention it last week. We got to be able to sketch a quadrilateral and label 2 things about it. So review that as well. Okay. Set. Go ahead. I'm just gonna do that first one, and you're on your own. But that way you have another go at it. There'll be 2 questions on expected value, right? So one is going to be a little easier, the other one is going to be a little bit harder, but the idea is the same. Okay, so in this game, if it lands on a triangle, you win $7. If it lands on a star, you win $3, and it will cost you $2 to play, right? So we need to make sure we subtract that every time from the prize, right? So given this spinner, I'm going to do this up here. The expected value of getting a triangle, you've got 2 out of 10 that are triangles, right? Given this. And then you would win $7, but you would pay $2 to play. So make sure you subtract that. There should always be a subtraction, unless it's a free game, right? So 7, the prize, minus the cost. And then there's another way of winning, so we got to add. So that one is if you land on a star. So there are 3 stars, right? So 3 out of 10. Don't worry about reducing in this one. Don't do that. 3 out of 10, and you win $3, but you paid $2, so that'll just be $1 gain, really. And you must have this at the end. After you've exhausted all the options of winning, there has to be a minus there. And they will usually not give you a losing probability. So you just need to do this, right? 2 and 3, that's 5 out of 10 percentage-wise has been used for winning. So that means that 5 out of 10 ways, there are 5 out of 10 ways to lose. And you just put the $2 there, which is the cost of playing. This is just the cost of playing. So the cost basically shows up every single time. Every single time it should be in there. Okay? And now you just clean it up a little bit. So I tend to turn this into a decimal if it's a fraction. So that's 0.2 times 5, right? This is 0.3 times 1. That's pretty easy, right? Minus 5 over 10 is 0.5 times 2. It's better to have expected value here, and then I'm running out of room here, so I'm going to go over here. And so 0.2 times 5 is what? $1, right? That's actually exactly $1, this part right here, if you type that into your calculator. 1 times 0.3, well, you guessed it, it's just going to be 0.3. And then half of 2 basically, but make sure you have the minus there, is 1. All of that is in dollars, by the way. So the expected value here is 1 plus 0.3 minus 1. So it ends up just being this, and it's $1 amount. So 2 ways of winning in this case, and then always have a subtraction at the end, where you just figure out how many ways are there to lose, given the winning probability. So that's what you should be getting there. Should he play the game? And the answer is yes. Expected value is positive. Gain expected. Okay. So that will be a full mark just to know how to answer that. Yeah. Go ahead. All right. The rest is on you. The answers are online already. But make sure you work. You shouldn't be on your phone, right? You should be working on this. Take time to do this. 15 minutes left.